We know that 1 centimeter cubed of cloud has 100 drops of water inside. Each drop has a radius of 10 micrometers. And here we have this cylindrical cloud here. So we're going to try to figure out the meters cubed, the volume of water that's inside of this cloud, knowing that there's going to be a whole bunch of drops inside of there. Okay, so if we're trying to find the V of the H2O, the total volume of water, what we need to do is figure out the volume of this cloud. So take the volume of the cloud. The volume of the cloud is going to be kilometers cubed. So essentially, it's going to be some kilometers cubed. Now, we have to convert the kilometers cubed, and we have to make it centimeters cubed. So that way, we could take the centimeters cubed that we have and turn it into drops. From there, we could take the drops that we have, the drops, and figure out how much the water is inside of each drop. Of course, this is going to give us volume in micrometers cubed, so we also have to convert that micrometers cubed into meters cubed. So we have to sort of take this in a series of steps in dimensional analysis. Let's figure out what the volume of this cloud is. The volume of this cylinder is just going to be equal to the pi r squared, which is the area of the circle on the bottom, pi r squared, times the height, which is 3 kilometers. So whatever. But we're going to plug that into here. So we have pi, and then the r squared is going to be 50 kilometers squared times 3 kilometers. And then we have to multiply that by this conversion factor here. So if we have 1 kilometer cubed, then we want to figure out how many centimeters are in there. Well, we know that a meter has 100 centimeters, and there's 1,000 meters inside of a kilometer. So that's going to be how many centimeters cubed we have. We also need to convert that 1 centimeters cubed to the number of drops. We were given that. So we get 100 drops right here. For every 1 drop, we need to figure out the volume of water in there. So what's the volume of a sphere? It's going to be 4/3 pi r to the third. So we have to plug in 4/3 pi, and then we're going to have 10 micrometers to the third. But of course, that gives us the volume in micrometers. So let's go ahead and take micrometers to the third and convert that to meters to the third. In order to do that, let's just realize that we have 1 e to the negative 6 meters per micrometer, and we'll take that to the third power. So if we plug all this into the calculator, it should give us the volume of water. But let's start step by step. We're going to go pi times 50 squared times 3. So that should give us the volume of this cloud right here. This is going to be in kilometers to the third. So we need to cancel that out by multiplying it by this factor. So it's going to be like 100 times 1,000. And then we have to multiply that by the third power. Boom. So now we have the number of centimeters cubed, which we have to multiply by 100 to get the number of drops we had. And the drops are going to cancel, and we have to multiply by this number, which will be 4/3 times pi times 10 to the third power. I'm not doing anything weird with that 10. I'm just putting it to the third power, because now we have the number of micrometers. And in order to get the number of meters, we have to multiply it by this number, which is going to be 1 e to the negative 6 to the third power. And now we've figured out that the volume of H2O is going to be 9869604 meters to the third power. Our next goal is to try to figure out how many 2-liter bottles can we fill with this much water. Well, if we know that we have 9869604 meters to the third, well, let's try to convert that to liters. But first, let's take a couple of steps. So first, we're going to go from meters to centimeters, and we know that there's going to be 100 centimeters per meter there. So we're going to cube this 100, and then we have to go from 1 centimeter. That turns into 1 milliliter. Well, that's fine, but there's not enough milliliters, so we need 1,000 milliliters to make 1 liter. And so now we can convert this into liters, but that's not going to be the number of bottles yet, but we'll figure it out. So we'll take our answer, and we're going to do 100 to the third power here. Third power. Okay, so that's the number of centimeters now, and then that's going to be the number of milliliters. no need to do anything there. But let's divide this by 1,000. So that gives us the number of liters. But we need 2 liters per bottle, so let's divide this by 2. So that will give us the number of bottles. We have like 493480201 bottles or so. The final question is asking how much mass of H2O do we have? If we have 9869604 meters to the third, and we're trying to figure out how many kilograms that is, well, we just have to multiply that by 1,000 kilograms because, well, that cancels out with the meters to the third. And so that would just give us the answer to the next one. So we just multiply that out, and it's going to be 9869604,000 kilograms of H2O. It's going to be the mass.